Hello, so in this video, I'm going to give you more example on how to use the chain rule. Here, fx equals to e to the 3x squared plus 2. So first of all, you look at the function, you need to think about, hey, can I use the regular rule, such as the product rule, the quotient rule? Does this work? No, because you see in the exponent of e, we have a function here, which is 3x squared plus 2. So you can consider this function as fx. So by the definition, let's not use fx because we already have fs. Let's use as another function g of x. So we can see, hey, e to the g of x is a function, or if you're uncomfortable with g of x, you can consider it's a letter a or u or any number. So when you try to get the derivative, when it comes to chain rule, it should be e to that function times, you need to get the derivative of that function. Consider that is a whole thing, which is e to the u or e to the g of x, and then you take the derivative of that function. Okay, so, or if you don't use the function notation, you use the letter u, you should consider that, hey, I'm taking derivative e to the u and then times u derivative. Okay, if it's e to the u, so how do you get derivative? Differentiate at u. So this should be equal to e to the u, and then u derivative, which is 3x squared plus 2 derivative, x squared plus 2 derivative. This is equals to 6x plus 0. And then u, we need to substitute u back, which is this function, the original function, which is e to the 3x squared plus 2 times 6x. Okay, so now let's try another example. So if I want you to calculate the derivative of ln x squared plus 1. Again, if you look at ln, we learned the derivative, the property, the rules. Ln to the x is equal to 1 over x. Sorry, 1 over x. But we never done something that ln to a function. So this is a function. So what you can do is apply the chain rule. So for the chain rule, I have ln to that function and then times the derivative of that function. So you need to get the derivative differentiate at g of x. So that means I can consider this as a whole. That means ln to x, I differentiate at x, is going to equal to 1 over x. So in this case, I differentiate at g of x, so the function is equal to 1 over g of x times the derivative of g of x, which is x squared plus 2, because we let g of x equals to x squared plus 1, I'm sorry. So this is equals to 2x. So when you rewrite that, I will have x squared plus 1 times 2x. You can write it nicely, which is x squared plus 1. Okay, now let's get another example. What about this one? Fx equals to ln 1 plus e to the y. And then this is y. We don't necessarily always x. So they want you to find the derivative of this function, f of y function, with respect to y. So that means you want to differentiate at y. Again, this part you can consider is a function g of y. So I have ln g of y times g of y derivative that part. Okay, so for ln g of y, I derivative at g of y. So this should equal to 1 over g of y times the derivative of g of y, which is 1 plus e to the y derivative. So I will get 1 over 1 plus e of y times 1 derivative equals to 0. E of y is equals to e of y. So when it comes to chain rule, the difference is the first part, you are trying to get the derivative respect to the whole function, which is g of y. For the second part, you get the derivative of that function respect to the variable y. Similar to here, the example here, which is you get the derivative of ln to g of x respect to g of x. But for the second part, you get the derivative g of x respect to x. Okay, let's get another example, which is I want you to get fx equals to, let's use another notation because we haven't talked about at least this notation for a long time. In fact, they both means derivative. Okay, so they want you to get the derivative of this function with respect to x, right? Because they tell you here is respect to x. But as you can see, we learned derivative how to do the exponent, but that is because the base of that exponent it just have one variable. We never learned a function exponent to get the derivative. So that means we need to use a chain rule because inside the parentheses it is a function. So that means when it comes to the function, let's let whatever inside the parentheses equals to a function g of x or any h of x, any letters that you want to use. So that means this is equal to, I get that part g of x to the cubic power respect to g of x times the derivative here, the derivative of g of x respect to x. So okay, so now for the first half part, we want to look at the g of x as a whole number because you try to get the derivative respect to g of x. So that means this is equal to 3 times g of x to the square or second power times the derivative of g of x, which is our 2x squared plus x. Well, 2 of x plus x derivative. Now when I substitute everything back, I will get 2 of x squared plus x to the 3 times 4x plus 1. So that would be the final answer. So I gave an extra for example on the chain rule. So please let me know if you have other questions or if you need help with chain rule, please let me know. Oh, sorry. Here should be second power because it's 3 minus 1. All right, I'll see you next time.